This is the beginning of a series of videos that's going to walk you through uh, starting from scratch and drawing a reasonably nice aircraft in SolidWorks. We'll go through lofting, some blending topics, some internal structure elements, and just some different nice practices to help you draw aircraft. Now, I should say that this is based on your prerequisite knowledge of SolidWorks basics. If subjects like extrusion or lofting or perhaps sweeping seem foreign to you at this point, if you're not really accustomed with sketching and all the other basics of SolidWorks, then do go pay attention to a SolidWorks basics course. Plenty of video tutorials exist for that, and we'll come back here and start together at a reasonable spot. But for the first set of lessons today, I'll be going over how to model reasonably accurate airfoils in SolidWorks. You'll find in some cases where actually my preferred method, at least, is not as numerically perfect as you might like, but in terms of shape, accuracy, I think more than gets the job done. So like most things, we'll just start with a new part. And in fact, what's interesting is I should explain that we're going to be creating SolidWorks blocks, almost like building blocks, you can think of them that way. They're more like stamps, I think, but SolidWorks blocks to be able to duplicate, size, scale, rotate whatever airfoils very easily between files. The first thing I always do is change the background to plain white. Adjustment. First of all, it's just more uniform. I don't really need the nice little faded appearance of the fancy background. So plain white is also nice. So if you ever take a screenshot or a screen snipping of your working environment, you can put that straight into a document. You don't get that awkward cut off faded background. It blends in perfectly with the document. It looks much more professional. So you'll see in most of the tutorials here, first thing I do is go in there and change the background to a pure white background so it matches documents and publications better. Anyway, straight on to airfoils. Let's go ahead and make this, it doesn't really matter, on the top plane, but we'll create a new sketch. And this is where we get into the first tools. The workflow in principle is going to be underneath tools. We will be adding in an image, so sketch tools, and we'll be going into sketch picture. Now I've gone ahead and saved two different PNG images. These are just images of two different airfoils, a 4412, I think that's an NACA foil, and an Epler 423. These are just screenshots, pictures acquired of airfoils however you want to. Airfoiltools.com is presently a very good resource to acquire many different kinds of airfoils, many more than you'd ever really probably need. But we'll start with the Epler 423 just because that's interesting and it's complex as well. So this image import is nice. There are some built-in SolidWorks scaling tools. Basically, I think this blue line is the scaling reference. In fact, it is for sure. But I'm a little bit old school. There was a feature added in subsequent versions, so I'll just say OK for the picture for a while and just draw a unit length line. I'm going to change this to a construction line. Notice that the picture is gigantic in comparison to 1 inch, so I'll change that here with this button. Notice that was a right click on it and I hit construction geometry, turns that into a dashed line. And so now that's going to be 1 inch-ish long. Yeah, I'm working in IPS down here. By the way, that's where you change your unit system, but for aerospace applications here in the US, we use inches, pounds, and seconds. Alright, so let's go ahead and start scaling this down to a unit length. You just double click on the image to go back into editing that. And just shrink and get this approximately correct. It'll take a bit of negotiation because what you want to do is go from the forward coordinate point, not necessarily the stagnation point, but probably very close to it, to the trailing edge. So the most forward point to the most trailing point. See, it takes another adjustment here to get it right. And this will just keep things nice and level. Notice that also matches the definition of 0 degrees angle of attack for an airfoil. So I'll go ahead and say OK to the picture. That should leave it in place. Now this picture is just in the background. SolidWorks doesn't know those are lines. It's just pixels. It doesn't care. The way we transfer this into a shape that SolidWorks can use is by using the Spline tool. If you haven't been exposed to this, you'll be using it a lot in aerospace. And at this point, you're probably saying, wait. Airfoils are made of points. You can download the DAT files. Just import the points, spline through them. Everything will be fine. It'll work great. Xfoil does that. Many other aerospace software packages do that. And you're right. Possible to be done. Certainly it does work, but the thing that's hiding in the background of all these spline algorithms is that they make some different assumptions. which endpoint, which derivative, which component of the spline algorithm is held constant or assumed to be 0, can change how the spline propagates, how many ripples you get internal to it. And really, in a solid modeling program especially, we want the surface to be simple, and we want the curvature to be simply represented. We want to minimize ripples and high-frequency noise that can cause a 3D model to break. So for that reason, and a few others that are a bit smaller, I just represent this with a minimum number of points. And now I'm going to place a few just for the top surface of the airfoil. Now that was beginning point 1, 2, 3, 4. And keep in mind the Epler 423 is a reasonably complex foil. The way I get this shape to match even better, though, is by clicking on it once, and you see all these handles appear, all these different gray lines. In fact, if we zoom in on the leading edge line, you see that it's basically a vector. The length of the line indicates the strength of that handle, meaning the influence coefficient of that handle, if you might call it that. You have the arrows that point in kind of the radial direction, which allow you to adjust the angle of that handle. You have the arrow that points just in the length direction, which allows you to adjust length but not direction. Then, of course, you can just grab it by the very tip right here and adjust both simultaneously. That's probably the better option. But for the leading edge point in particular, I usually try to make it vertical. You want both the top and the bottom lines to depart from the stagnation point, that 0, 0 coordinate point, in a roughly vertical orientation. And now I just adjust the length till it more or less matches, biasing my adherence here to the front portion, more or less matches the airfoil shape. And now, yeah, the perfectionists among you might say, well, this is inaccurate, I hate this method. And okay, fair criticism. It's not perfection, but this is probably dealing down in the hundredths or thousandths of an inch, where your eventual sanding of the airfoil on the mold you're making or in the product you're building will have a much bigger influence on the actual constructed shape than whatever minuscule deviation you see here. All right, so you see we can just go through here and tune these relatively nicely. It does force curvature continuity through these control points, but the magnitude left to right can be different, so that just with some practice, and the first time you do this, you won't have maybe the intuition developed in your mind yet to know exactly what and where to adjust. But hey, that looks pretty good. Well, actually, I readjust this here in the front. Some changes to that second spline cause the front to change, and honestly, I'm pretty happy with that. So that's the top vector. That's the top spline taken care of. Let's do the bottom spline. Hopefully Solidworks sticks with me. I know this installation of this fresh installation of Solidworks has been a bit crashy as of late, so hopefully that won't be an issue. In fact, I'm going to save it right after I finish the spline for that concern. It's a good practice to relay through video, right? So actually, same number of control points, only 5. If you remember DAT files on Airfoils, they have hundreds of control points. Let's go ahead and save this to back up our work. So you have SolidWorks Aerospace Lessons, Airfoil Practice. All right. So again, just the same way, click on the bottom part here, make this front one vertical after getting it approximately in the right spot, change the length, and we're good to go. So it's important to do the top and bottom splines top and bottom surfaces in 2 different splines. If you do them as one spline, first of all, it's going to want to make this trailing edge curvature continuous, which it's definitely not, right? Cut a condition, you want it to be a sharp trailing edge. So curvature continuity is just not going to fly. Get it? It's an airplane joke. So actually that took very little adjustment and we're pretty much there. So that's good. By having a top and bottom spline as well, you are creating a nodal connection in SolidWorks. This allows for the eventual surfacing panels to be divided at the leading and trailing edge, allowing you to easily manipulate, cut, and do geometric operations on the top surface or the bottom surface independently. So there are multiple reasons that a top and bottom line separation here makes sense. So really, this level of accuracy, notice it's actually a little bit off there. I could probably adjust that if I wanted to, but don't go crazy. Keep in mind, people will be sanding on this with very coarse sandpaper most likely. So unless you're working on a multi-million-dollar program, it's good enough. All right, so what I'm going to go ahead and do is just escape that, save again, because I like where it's at. And before we go much further, I'll just look it over, say I'm good. All right, the step now that actually makes this useful for multiple places is to go to Tools, Blocks. We should be able to go Make. I probably have to be back inside the sketch to do a Make block. Tools, blocks, make. Yeah, so you have to be inside the sketch, and you know that by being able to exit the sketch or cancel sketch changes. You can also tell where you're at by other methods of, by other parts of the SolidWorks screen. So again, Tools menu, blocks, make. And so this is where you're actually going to create the stamp, the file that you can save on your computer to go between any number of SolidWorks SolidWorks projects, and bring in this Epler 423 foil, and you'll see how useful this becomes in a few steps from now. So block entities, I want the top line, I want the bottom line, and actually I'll probably go ahead and bring the datum line with us. The other thing I want to do is turn on the insertion point, and for the sake of being able to dictate that wherever I click in the future, I want to place the stamp by clicking where I want the leading edge point. So I'll drag that insertion point down to the 0, 0 location of this airfoil, the leading edge stagnation point. We should be good to go. So I'll say OK, make the block, and it's made it in this file. It only exists inside the SolidWorks file at the moment. It's not that's not the most useful we can make it, but a couple operations here. I will go ahead and right click on the picture, and should be able to hide it. Not just hide or show it in the tree. Well, maybe I'll hide it afterward. I don't want to delete it. Not that it's linked to anything, but nope, that's definitely not going to do it. All right, we'll hide that after we exit the sketch. It's probably won't let me do it from inside. So on the block, you just right click and you say Save Block, and now you can put this anywhere you want. You can say this is an Epler 423 airfoil. It'll be saved as .sldblk on the desktop, and we'll just click Save. Alright, so there's the airfoil, there are the top and bottom surfaces, and then now that we can escape the sketch, should be able to, yes, suppress the picture, leaving us just with the geometry that SolidWorks knows what to do with. So that is the information that's saved within the block. You can always go back in and edit it and change it if you want to, but to show you how useful this is, I'm going to actually just close out of that file. I'll save it all, but notice we're back to nothing. All the files are closed. And then to make the point and why you want to bother with blocks, I'm going to create a new file. Just a simple part. I'm going to make a little wing. Actually a fairly complex wing, but this process makes it very simple. Change it to plain white background so you can import this into documents very nicely. I should demonstrate that point at some point in these lessons. Let's go with the right plane, like you would be dealing with on an aircraft. The wings you typically leave the right plane somewhat perpendicularly. Let's create a sketch there, and we go to Tools, Blocks, Insert. So now it asks us to browse for the block. I saved it on my desktop, so there's the Epler 423 file. Now that becomes a block. Now look, notice that it follows my cursor by the insertion point that I selected. I can add it to a sketch, and right now it's pretty small. But since we made it a unit length long, if I wanted a 15-inch airfoil, I scaled by a factor of 15. Pretty useful. You see where this is going, right? If I wanted 3 degrees of wash in or wash out, you type in the angle you want, and there you go. That's 3 degrees of wash out. To demonstrate that more extremely, 25 degrees. If you want to rotate it the other way, well, yeah, negative 25. But this allows you to very easily follow aerospace conventional definitions to create washout, wash in, whatever else you need in SolidWorks. And hey, this is stacking up nicely. I mean, you can sit here and add a bunch of these. You can do this with names. You can do this with any SolidWorks feature. We're just teaching this from an aerospace perspective, so that's why we use airfoils. Click Escape because I only want one airfoil. I believe you can actually go back in here. If you click it once, you can change it. So if you're like, oh, whoops, 15 wasn't right, let's change it to 13. It's not stuck there forever in a unreasonable fashion. You just click once, change the angle. And what's neat is you can do this even after the airplane model is finished. If you've been robust in your definitions and the links in SolidWorks stay maintained, you can actively change washout. You can actively change shapes. You can swap out one airfoil for another. And through other combinations, you can see that eventually this will grow to, you could potentially run multiple CFD studies with different wings, different shapes, different foils, different elements. And okay, now you're getting sophisticated with it needing a lot of computation, but hey, that's where your brain should go, to the extremes, to the fun, innovative sides of engineering. So hey, that's the root airfoil. Now let's go out here, create another plane. Not another airplane, but another geometric plane away from the right-facing panel there. Let's go out, I don't know, 24 inches. I'm just making up these numbers as we go. So perpendicular to the right plane, we now have plane 1. I'm going to create a sketch on that plane. go normal to it. I'm pressing spacebar to bring up that menu, by the way, if you're not familiar with that. Really handy dandy way of looking around different directions of things. Most convenient one, I think, is the normal to button. I use that all the time. Let's go ahead and go to Tools, Blocks, Insert again, Epler 423, except I don't want it the same size. Let's do something more engaging. Wait, why does that still say 1? That's interesting. Okay. Let's go to a scale of 8. Yes, okay, so now that we changed it from a non-Unity scale, it went back to normal. So we can see that 12 should match, or what do we have the previous one at? 13 inches maybe? Yeah, 13 matches the root. So let's actually go to a little bit smaller for the tip and make that 7 inches in chord length. Instead of having a, well, I guess I need to update that to 0 if I want it to be. Interesting that it's causing any sort of concern there at all. That's interesting. It seems to be that's a different behavioral feature than previous versions of Solidworks. It seems to be referencing the open block and not the file block. How curious. Oh, now it wants to behave. Okay. So just open the file block again, and then seems to be as predicted now. So this wing doesn't make much sense. It'd have wash in, so the root would actually be at a lower angle than the tip. So let's prepare the tip of the wing to have a little bit of washout. Okay. Place this with 0 leading edge sweep. The trailing edge will actually come forward. So this will be technically a forward swept wing. Kind of goofy, but neat. And go ahead and leave that sketch. Let's adjust the root sketch so we have a more reasonable aerodynamic surface. It just tweaks my brain to leave it as it is. So let's click that once. Instead of 5 degrees of washout, let's go to actually a couple degrees of incidence. So 2 degrees nose up. Exit the sketch. So now you have these two sketches positioned in space where that would be cross sections of a wing you might want to design. Let's go ahead and save this so we don't lose work. Simple wing. And do a surface, which, by the way, if this tab is not open, just right-click up here on the tab list and check the surface box. That'll make the tab appear, and then now you have all of the same, or similar, and more, tools that might exist as a solid feature. You can now do similar things with surfacing, but it becomes a mathematically thin, infinitesimal surface, just really as a definition more than it is a solid. Okay, so to go between these two, I want to do a lofted surface from the root foil here to the tip airfoil there. Now it didn't give me a preview or anything because the connection is crossed. The trailing edge is trying to connect to the leading edge, and that's not going to work so well. All you have to do is grab it and move it, and that one looked easy. Sometimes those control points are somewhat difficult, also known as extremely difficult to move in Solidworks, but keep at it, trying from different directions, and it'll work. So right now you see that this automatically did a linear interpolation in 3 dimensions between the 2 defined airfoils, so that you can go across your wing with any sort of washout, dehedral, sweep, whatever you want to apply to a wing, and it makes sure that the airfoil sections stay consistent in the geometric, streamwise sense. So for now, that's the simplest surfaced wing you can make. Of course, you can do a simple solid extrusion as well, but this is quite nice. To demonstrate the point I made earlier about being able to modify the geometry, let's first turn this into a complete wing, left and right. By the way, most aircraft are only modeled on half the airplane. Very few aircraft are actually asymmetric on their left or right side, port starboard side. So the detailed modeling happens on half the plane, then there's just a lightweight surfaced mirror that brings that geometry over to the other side. So I think we have to go back to actually the Features tab to do a mirror. There's no surface-specific mirror. It's all the same tool. So let's go Mirror. The mirroring face and plane is the base right plane. Please, please, please follow aerospace conventions for the front, top, and right, and the origin locations. The Feature to mirror, actually I want to do a surfaced body mirror, so we'll do that. Go straight across, and that makes it really easy to make a wing that goes across left, right. Now this is kind of odd. It's a forward swept, extremely high camber with slight washout. And that wing is unusual. Probably doesn't make much actual aerodynamic sense. 0 dehedral, yeah. By the way, to add dehedral, let's show you how you would go about that. Both of the sketches you use to make the wing, save, backup. You should be able to set an auto backup in options. Both the sketches are now contained within the surface loft drop down in the menu. So sketch 2, I want to right click on it and edit that. Instead of sharing this control point with the leading edge point of the base wing. I want to be able to move this sketch. I'll still keep the... No, I will. I will actually change it up. Instead of having 0 leading edge sweep, let's establish a coordinate system between the two. So 24 inches out, I want the leading edge to be 2 inches back. And I want it to be... Oh, nope. Not the definition I want. Mash the escape button a bunch. Between those 2 points, I want it to be, let's say, 2.5 inches up. So that now defines the dihedral and sweep of your wing. So we'll say OK, and look, it automatically adjusts. The wing is now even a bit more odd, but that's what you've got. If you wanted to go back through and even modify your airfoil, maybe you got the taper ratio a bit wrong, you need more chord out towards the tip, change that to 9 inches, stretches the sketch, escape, escape. Well, look at that. Now the wing's a bit different. So that type of geometry and quick update, hide this plane because it's in the way, is really, really, really handy for defining aircraft shapes and doing lots of quick conceptual design images and layouts. So really, really I like this. And before I close out the first lesson, let's show you why I deal with a white background. Let's say you're going to put this wing as one of your conceptual design options into a report. If I use the snipping tool and take a quick snip of that surface, you'll see, if I can get the tool back up, there we go. That image would copy and paste into a document perfectly fine. Now let's turn back on the SolidWorks default and have a 3-point faded background, do the same thing again, retake the picture, and I want to grab the wing. That is what would be copied into your document. It's a bit worse than normal, so okay, let's let the computer have another chance. Still, we got rid of the ghosting, but now that's what goes into the document. See this kind of the gray background that's extremely obvious now if you're going to be going into a document. Some people try to hide it by either, by hand going here and tracing the item, or they use some automatic background removal tools, and it just really never works out as good. So please, in all the things you copy in a document, go to plain white background, snipping tool, new, so much easier. Just copy pasta that right into your report, and you'll be good to go. All right, so that's the first lesson of quite a few for aerospace specific SolidWorks design.